In this video, we're going to talk about linear functions. So we've talked about what functions are in general. We're going to talk about this specific class of functions, which are just going to be lines. We've already talked about lines as well. So if we notice about the graph of any non-vertical line, we get a function. It's because any of these graphs will pass the vertical line test. So just to look at an example here. Here we have a line that's positively sloped, this red one here, and certainly the grid even helps here is that any vertical line will cross that red line exactly one time, so certainly passes the vertical line test and will be a function. This blue line is representing a negatively sloped line, and again, looking at our grid lines that help, certainly those lines intersect that blue line exactly one time. So any non-vertical line will be a function. We wouldn't want to talk about our vertical lines being functions because notice a vertical line certainly would not pass the vertical line test because that same vertical line would intersect itself in more than one point. It would intersect itself in infinitely many points. All right, so this leads us to a definition. A linear function is a function that can be written in the form f of x equals mx plus b, where the m and the b are real numbers, and notice this looks a lot like our slope-intercept form that we have for lines. So in fact, if we just trade out the f of x and put in a y, we get exactly the slope-intercept form. So that number m in the form of a linear function is going to give us the slope, and that number b will tell us that the y-intercept is the point 0, b. So if we're looking at an example here, this one wants us to graph the function. F of x is 5x minus 9 plus 12x all over 3. Well, we know from what we've worked with lines before that if we want to graph a line, probably be helpful to know its slope and its y-intercept. So the first thing we're going to do here is we're going to simplify this function so that we can see the slope-intercept form. All right, so start with our function. One way to think of this is the same thing as negative 1/3 times the quantity 9 plus 12x, which means we can distribute that minus 1/3 through. Minus 1/3 times the 9 gives us the minus 3. Minus 1/3 times the positive 12 gives us the minus 4. So now we've got 5x minus 3 minus 4x, or simplifying that down, we get x minus 3. Again, if we think of this f of x as being y, then we've got the slope-intercept form of y equals x minus 3. The m value here would be 1 then, and the y-intercept would be the point 0, negative 3. And that allows us to get a graph of the line pretty easily. If we start at the y-intercept and we go right 1, up 1, because we got a run of 1 and a rise of 1, plot another point, right 1, up 1, plot another point, right 1, up 1, plot another point, and draw our connector dots here, we get this green line that's in the graph here. Just mentioning one more thing about this simplifying here. This minus sign out in front applies to the entire numerator, and this 3 would apply to the entire numerator. That's why I wrote it out as a minus 1/3. You could have done it. You could have taken the minus sign and distributed it across the top, taken the 3 and broken it up at the plus sign. There's a couple ways you could have done this, but importantly is that make sure that these things get applied to everything on the top, not just the front piece. All right, let's do another example. Let's say this problem asks us to find the linear function that passes through the points 5, 3, and 7, -1. Well, if we're going to find the linear function that passes through these points, really all we're being asked to do is find the equation of the line that passes through those points. Two things that we need for an equation of a line are a point and its slope, and then we can use point-slope form. Let's find the slope first. Slope is rise over run. So I take the difference of my y-coordinates, y2 minus y1. Actually, the order doesn't matter as long as you have the order the same on top as on bottom. And what I mean by that is since I'm doing -1 minus the 3, I need to do the 7 minus the 5 on bottom. Okay? You could do 3 minus a minus 1 on top, but then you'd have to do 5 minus the 7 on bottom. You got to keep the order the same. Anyway, when you simplify that arithmetic, you get m is equal to -2. Like I mentioned before, We can now use the point-slope form to find the equation of the line, and then we'll solve for the y to put it in slope-intercept form. All right, so point-slope form, remember, is y minus y1 equals m times the quantity x minus x1. So y minus 3, I'm going to use the first point. You could use either point you want. I'm going to use the first point here. You should check by using the second point that we'll get the same slope-intercept form, though. Be a good exercise to do. Y minus 3 equals m, the negative 2, times x minus 5. And again, we put this in slope-intercept form by solving for y, so we'll distribute the negative 2 and add the 3 to the other side. So this is the linear function that passes through those 2 points.